Filed under Fool's Rush In, where angels fear to tread, I thought today I would give you the quick run through of Intech's offering of pH and conductivity solutions, and I'll focus today on pH. Now, a mea culpa up front. There are many people who know a great deal more than I do about pH, including my mate Owen Braybrook from Hark. And I'll copy him below if you want to get into depth much more than I can possibly begin to offer. In nearly all cases, with the notable exception of ISFETs, a pH probe consists of a glass bulb with some contents we'll talk about shortly that one inserts into the solution. And because of that, and the glass is quite special, and because of that, one needs to treat it in a special way. You'll see here that um, in the case of this probe, we're stored in a pH neutral solution, and similar on this one. So let's quickly talk about the products that Intech do. Jumo is one of our premier brands out of Germany, and they make some tremendous probes. We'll talk about the three examples that we have in the catalogue, but there are a plethora more available to you. And then from a Swiss company called Innovative Sensors, now owned by Endress and Hauser, we have a good range of excellent quality, well-priced sensors that we can offer as well. Now, what is a pH probe? How does it work? Well, our old friend water, H2O, auto-ionizes. So if we look at H2O and we have it at room temperature, and by itself, it will auto-ionize into H plus ions and O minus. And in some cases, the H plus will form hydronium, and this is H3O. And pH is effectively a measure of how many hydronium ions we have. At pH 7, I won't go into that. But long story short, it's a measure of how many free hydrogen ions we have. Now, to measure that, we have a special piece of kit, the pH probe. It's made of glass, but it's not glass like we used to. It's a semi-permeable layer. Inside the bulb, we have a solution of KCl typically, and we have a electrode which is silver. And across the semi-permeable membrane, the hydrogen ions react with the negative ions inside. And this generates a small voltage, which is what we measure. Typically, there's a slope, and um, per pH, we have minus 59 millivolts per pH. So we get a measure across there. Now we have to compare that with something, and we have a reference electrode, which is another electrode up here in its own solution of KCl or similar as a reference. Now, it's important to know that pH measurement is very temperature sensitive. So one needs to have either a built-in temperature sensor or a um, or a separate PT100 probe that measures and compensates for it. So let's take a look at the probes that we have. As I say, this is merely a very brief look at it. Within the probe, we need to have a grounding diaphragm effectively. That is a source where the fluid in which you're measuring can react with the fluid inside the probe. And that's done through a thing called a diaphragm. In the case of the three probes we show here, we have two ceramic diaphragms. Let's see if we can see that diaphragm to give you an idea. Yes, hopefully you can see that. There's a very fine, um, sort of a few hairs width of Teflon typically, or ceramic of some sort, that allows the fluid inside the cell to react with the fluid outside. Now, in the case of this probe, it has a single one. In the case of the unit mentioned here, we have two ceramic diaphragms, and this means that it will work better in a fluid moving situation, where there's flow is the word I'm trying to find. Um, a single ceramic diaphragm is common, and the other option is a glass fiber diaphragm. Now, it's important to know that the diaphragm is going to be exposed to your fluid, and if you're using something like drinking water, something pure, okay, great. But if you're going to use it in a nasty environment, that tiny diaphragm is going to get blocked very quickly. And quite commonly, we see a larger sensor for the earthing uh, element. So in this case, on the Anderson-Hauser probe, we see a large Teflon ring. So this provides a much, much larger contact area for the grounding electrode. So one would use this in a situation where the water was less than pure. There are special bulb designs for protection from highly viscous fluids and for deeper penetration, etc. So if you want to talk more about pH, talk to Intech Instruments, sales@intech.co.nz.